Hello, my name is Oliver Maiß and I lead the Research and Development Department here at ECOROLL AG. Today I have brought you an application example from the aviation industry where I would like to show you how deep rolling is used on stretch bolts in aviation to ensure fatigue strength. Stretch bolts are incredible. They are important components in aviation because they are meant to create a secure connection between two elements that are subjected to strong vibrations. These elements expand to different extents, meaning they undergo different deformations due to thermal effects. And in these applications, the tension bolt is always supposed to ensure that the two components remain securely connected. The tension bolt we worked on here is part of the engine mounting, so this tension bolt is used to secure the engine. That means it is a very safety critical component. If the tension bolt fails, it can have very serious consequences. The task our customer gave us was, I have such a tension bolt, it's good, it's light, it works, but it doesn't quite have the required fatigue strength yet. This really has to be guaranteed 100% of the time, and that's currently not quite the case. We should try to apply compressive residual stress to this tension bolt in order to reliably achieve fatigue strength in all cases. Of course, we were very happy to take on this task. To go into a bit more detail, I've brought the component here along with the tool and process. The tension bolt is made of a titanium alloy. The titanium alloy has a strength of 1600 megapascals and a hardness of 49 HRC. Even just the machining parameters for this material are very challenging in cutting operations. So it's a high-strength material, titanium, always difficult really in all its machining variants and also when it comes to deep rolling. Nothing about it is easy, but we managed it with an HG6 tool. More precisely, we used an HG6-9 tool. For us, it's a relatively simple standard tool where an HG6 rolling element, that is a 6mm ball mounted on a refill system, is attached to a clamping bar. Here we selected the clamping bar so that the rolling ball is positioned at 0 degrees on the surface. That means there is no tilting of the ball. Instead, the ball is truly perpendicular to the surface at that point and can therefore work optimally. The ball is pressed onto the surface with hydraulic fluid, ensuring we have a secure contact force. Here we used a contact force of 750 newtons. That corresponds to about 300 bar of rolling pressure. In this case, the rolling speed was 150 meters per minute, and we chose a feed rate of 0.1 millimeters. This is just high enough to ensure economical processing, but at the same time covers every area of the surface. We can process it with sufficient overlap. With these parameters, we processed this tension bolt in 28 seconds. So the main processing time was 28 seconds, which is reasonably fast and fast enough for our customer. What was the outcome for the customer in the end? The customer managed, or rather together with the customer, we managed to reduce overall manufacturing costs by 25%. Compared to the alternative process, we are now 25% more cost efficient. At the same time, we reduced the production time by 30%. That means we've also become faster. And of course, the most important point for the customer, we definitely achieved the required fatigue strength. 100% of the components that we deep rolling and tested achieved the required fatigue strength. This was decisive and has led to the fact that even today, the tension bolts are still deep rolling using our tools. With that, I would like to sincerely thank you for your attention. Feel free to share and like the video, discuss it with your colleagues, and if you have any questions, of course, don't hesitate to contact me or my colleagues here at ECOROLL AG.